Okay guys, so I'm still in 4.7. I'm on page 410 here, and we're going to just keep going with this section. So we've already been talking about maximums and minimums of parabolas, and we've already kind of reviewed what this means. So now what I want to do is I just want to do a quick set of exercises to check your understanding. So using what you know about now maximum and minimums, so if this were my quadratic, or if this were the parabola I'm supposed to graph, and this is the answer that this student drew, how would you know right away that there is an error here? Well, you know because this is negative, so my a is equal to -2, so that means that the parabola should open down. So that's kind of just what I'm looking for here, just a quick little check of like, how do I know whether or not these are right or wrong? Okay, now example 6 here, there's still an error, but this time it's not quite as obvious. So I want you just to take a second to kind of look at this and examine this and see if you can figure out what the error is. So maybe pause, hit play when you think you've found it. Okay, so just by looking at this, I can't tell what the error is. So what I want to do now is I want to just choose what's my A and my B, and maybe I just want to go back and look at what the vertex was. So if I figure this out, so let's see, 2 times 1, so this becomes +2/2, and now I can actually see what this is, right? So the issue was when this student was working this out, they should have gotten 1, instead they got -1, so the vertex is in the wrong spot. So it's actually just the wrong vertex. So those are just kind of there to do a quick check of just your reasoning and understanding with some of this, just to make sure you've got kind of the general idea. So now we're going to switch gears, and now we're going to talk about how to find intercepts of parabolas. Now, we've talked a whole lot about finding intercepts throughout the course. For parabolas, there's a little bit of a twist with it, but we have all the skills to do it. But finding intercepts is actually something really kind of key for graphing. So, so first of all, let's talk about finding the y-intercept. So the y-intercept is always just found by plugging in 0 for x, so that's always going to be the more straightforward one. So let me write that down. So you're just going to plug in x equals 0 to find your y-intercepts. So in this case, I'm just going to take f of 0, and you can probably tell what it is just by looking at it. So this is going to be just 6. So the y-intercept in this case is the 0.06. Okay, so that's like the nice case. Now the slightly harder thing will be, how do I find now the x-intercepts? Now for the x-intercept, usually what you want to do is you want to set the y-coordinate equal to 0 and solve. So let's take a look at what that actually looks like. Let's see, solve. Okay, so if I do that, so I'm going to basically take this quadratic here, and I'm going to set it equal to 0. So I get x squared plus 5x plus 6 equals 0. So the question is, how do I actually solve that? So you might be able to tell them by looking at this that you can actually factor to solve this. So we can use factoring in this case. So how would I factor x squared plus 5x plus 6? Well, this would be x plus 2 times x plus 3 equals 0. And then you just set each one of these factors equal to 0. So I'll show you what that looks like. So I've got x plus 2 equals 0. When would this equal 0? Well, you can go through and actually solve for x. You can subtract 2 from each side if you want. Or just by looking at it, you might be able to tell that x equals -2. And then for the other one, so I'm going to set the other factor equal to 0, and then I'd find that x equals -3. So my two x-intercepts have to do with these points here, but I'm not done. So to actually find the x-intercept, I have to state the point. So I'm running out of room here. Maybe I'll just write this out in orange. So the x-intercepts, these are the points -2, 0, and -3, 0. So you have to actually state them as points. So this is very similar to something we were doing earlier in the course. This was from chapter 3. So actually this was all stuff from, let's see, maybe I'll mark it here. If you want to review, it's page 298. We did a whole bunch of stuff with this, and now we're basically just tweaking it so that we can find x-intercepts. So we've kind of been like pushing towards this kind of throughout the semester in some ways. Okay, so what I want to do is I want to just go through a few examples with you, and then I'll give you some to try too. So I just want to find the x and y-intercepts of the following quadratics. So like I said, so for your y-intercept, so that one's going to be the nice one in that you just have to plug in 0. And so that will usually be the much faster calculation. So if I plug just 0 into this particular quadratic, I get just -15. And then you do want to make sure that you state this as a point. So my y-intercept is the point 0, -15. Okay, now to find my x-intercept, that's where this takes a little bit more work. You're going to set that quadratic equal to 0. And maybe you want to pause here and just take a second to think about how does this actually factor. So this factors as x minus 5 times x plus 3 equals 0. So then the two solutions to this particular equation would be x equals 5 or x equals -3. But remember, this is not, now it depends on what you're being asked, but in this case, since we're being asked to find intercepts, this is not the solution. Now we have to actually turn this into a point. So this would be 5, 0. And -3, 0, those would be your actual solutions in this context. So context really matters as far as like how you're going to format your answer. If I were just asking for what are the solutions, you'd tell me x equals 5 and x equals -3. But now I'm asking what are the intercepts, so now I have to state it as a point. All right, so let's go ahead and find the y-intercept here. And so once again, so I'm just going to plug in 0 for x. So maybe you want to do that on your end as well. So I'm going to plug in 0 for x, and I get 0 squared minus 7 times 0 plus 10. So my y-intercept in this case is going to be 0, 10. So now let's find the x-intercepts. So once again, I'm going to set this guy equal to 0. And again, if you want to pause just to figure out how it factors, hit play when you're ready. So this factors as x minus 5 times x minus 2. So I get x equals 5 or x equals 2. Those would technically be my solutions, but those are not my intercepts. So then I'd have to state this as 5, 0 and 2, 0. Okay. So I just want to kind of remind you of a couple different ways that this can work itself out now. So I'm going to do 3 examples on the next page. So let's start with just one where you have to factor. So you do this one totally on your own. So just find the x and y intercepts. So I want you to use the equation f of x equals x squared minus 4. So you can use factoring to figure this one out. So hit play, find the intercepts, or pause and then hit play when you're ready to see the solution. So in this case, so for my y-intercept, so I take f of 0. So this will be 0 minus 4, so this is just -4. So my y-intercept is 0, -4. Now, for my x-intercept, like I said, you can set this equal to 0, and then you can actually factor this, right? So this is the difference of squares, so this is x minus 2 and x plus 2 equals 0. So my solutions here are 2 and -2, so my two intercepts are going to be 2, 0 and -2, 0. Okay, so that's when you can factor. But here's the deal. Not everything's going to factor. So this is why we talked about a whole bunch of different ways to solve quadratics. So now I want to just show you some other things that can happen. So now let's say that I've got, instead of x squared minus 4, what if I had x squared minus 3? So finding the y-intercept is the exact same process. So I go through, I just plug in 0 for x, I'll get 0 minus 3, so I get that this will equal -3, so I still have the intercept 0, -3. Okay, now here's the kind of the tough part of this, the x-intercept. All right, so notice if you set this guy equal to 0, this will not factor. This will not factor because 3 is not a perfect square, so that kind of makes everything a little bit tougher. So this is where now we have to use some of our other quadratic solving techniques. So I'll just remind you, if you go to page 302, we use what was known as the square root property. So this is actually what we'd want to use in this case. And so if you want to maybe pause and just refresh your memory as to what that was, this would be a good place to kind of do that. So the square root property said that, so if I have something squared, basically I can set x squared equal to 3. So first let me just bring the 3 over like this. So I have x squared equals 3. So if you review the square root property on page 302, and this was from chapter 3 by the way, so you can find the video kind of referencing how to use this technique. A lot of people forget this one because we go through it and then we do a bunch of other things and then we come back to it later. So don't be surprised if you have to go back and review. That's totally normal. Okay, so I have this. So to finish solving for this, so I take the square root of each side. So the thing about the square root property though is when you use it, you have to take plus or minus. That's always the tricky part. And so I'd have x equals plus or minus the square root of 3. So I can either leave it as that, or if I actually want to figure out what's that decimal. So the square root of 3 is equal to plus or minus, let's see, this will be 1.732. That's what I'm getting. So you can use, in my mind anyways, you can use either one of these as the way to represent your x-intercepts. So if you want to use the square root, you'd represent your x-intercept then as the square root of 3 comma 0 and the negative square root of 3 comma 0. Or if you wanted to use the decimal, you'd have 1.7320 and then negative 1.7320. So it just depends on the answer format. I can't remember which way my math lab does it. It might be one or the other. So, you know, these would just be the two ways you could kind of represent this. If you're in my class, I mean, I'd be fine with this, but, you know, my math lab sometimes has a certain format that it wants to see things in. Okay, so that's one way you can deal with that. So I have just one more example I want to show you, and then we'll be good on this video. So the other way that this could come up would be something that maybe you can't use the square root property on. So let's say I have something like f of x equals, how about x squared minus 3x plus 1. Okay, so once again, if I try to find the y-intercept, the y-intercept's always like the nice one because it's just plugging in 0. So I can plug in 0 into this, so I get 0 squared minus 3 times 0 plus 1, so this will equal 1. So my y-intercept is just the 0.01. Now, this is going to probably take you a second to think about, but if I try to set this equal to 0, once again, you can't solve this. And if you need a second just to think through it and pause the video, go for it. So this cannot be factored, and we also cannot use the square root property. So then you may remember the next thing that we would do, so this is from page 303. So this is, maybe I'll just write page 303. The good old quadratic equation. Quadratic formula that I keep calling the quadratic equation for some reason. So anyways, we're going to have to use the quadratic formula here. So I'm going to assume that maybe you don't have that memorized off the top of your head. So I will write it out for you. This is negative b plus or minus the square root of b squared minus 4ac over 2a. So when you can't factor and you can't use the square root property, and you can only use the square root property if you don't have an x term here. So this one's fine. The problem here is that we have this extra x term. So because I have this extra x term, I cannot use the square root property. So now I'm really stuck. I have to use the quadratic formula. So now I've got to plug all this stuff in. Okay. So what's my a, what's my b, what's my c? So my a in this case will be 1. My b in this case is negative 3, and my c would also equal 1. So maybe you want to pause the video and just plug all this in and make sure you can figure this out, and then hit play when you're ready. So I get, this will equal, so this is going to be negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 1. All of this divided by 2 times 1. So there's what I've got. So I will continue to work this out over here. So this becomes 3 plus or minus the square root of 9 minus 4 divided by 2. And so then I get 3 plus or minus the square root of 5 over 2. And so now I've got to break this up into the two pieces. So I will calculate 3 plus the square root of 5 divided by 2. and x equals 3 minus the square root of 5 divided by 2. Okay, so if I work this out and I plug this all in, so I've got my calculator just sitting right next to me. So first I plug in 3 plus the square root of 5, do that, and then I divide that by 2. So I get 2.618 for this first one. And then for the other one, so if I take 3 minus the square root of 5, I'll hit the equal sign, and then I'll divide that answer by 2. This comes out 2.38, and I'll round it up to 2. So there are my two solutions. So this is like a way harder problem, right, if you can't just factor, but this is something that you should know how to do. So then my x-intercepts, so I'll write them in another color here just so you can tell what my answer is. So my x-intercepts then are going to be 2.618, 0 and 0.382, 0. So that's kind of your last-ditch effort if you can't actually figure out what the x-intercepts are. Ideally, you can factor, but sometimes you can't, so that would be what you do. Okay, so that seems like a good spot to stop, so I'll see you guys in the next video.